Excellent. Well, thank you so much. I'm really excited to share this work. So first, let me say I think it's a dual honor to be the one presenting this. The first is my Living and Working with Robots team, which I'll detail in a bit, is cross-campus, as so many of these projects are. It's been an honor to work with them. And then, of course, to share the stage with those other great projects. I've had extensive notes on a bunch of connections between them that we can follow up on, hopefully. So this is actually not the full team. There's one co-lead who didn't make it on here. It's Junping Zhao, who we heard from earlier, and it looks like he might have stepped out. Sam Baker, Luis Sentis is in the audience here. In an overview like this, I just want to highlight kind of the sources. Living and Working with Robots was built up on the foundation of an interdisciplinary robotics collaboration, right? And I suppose I'm starting to count less as a robotics outsider, but a year or so ago when we started this, I was. And to me, robotics was a thing, right? But within robotics, there are so many subfields. And so there was an interdisciplinary collaboration between Jordi Biswas, Luis Sentis, Justin Hart, Peter Stone, and Junping Zhao. And Sam Baker was the one who brokered the conversation because this group wanted to do delivery on campus. And they wanted to do so in a way that really met the goals of the Good Systems project. And they kind of realized, well, you know what, our research methods are kind of about robots, not about people and about communities. And so Sam brokered the conversation that brought on a social science team to this. And then as we started to think about, okay, delivery, yes, that makes good sense as a test bed. And the initial prototype was delivering free lemonades to students, which is great, right? That's a real world test case. You have robots delivering things. But we wanted to get integrated into the university's mission. And so we brought on stakeholders as core collaborators. That's Aaron Choate and Katie Pierce-Meyer. And so of the names I haven't mentioned, my colleagues Sam Shorey and Carrie Stevens from communication studies. So that's kind of our disciplinary range in the composition of the team. So our kind of mission statement is we build and study robot systems designed to benefit the specific communities in which they're deployed. Sounds good, right? I really think that skepticism in the area of ethical AI and ethical technology broadly is healthy. And so you can see the asterisk here. That's going to be a running theme in this presentation, and it's trademarked down there, tongue-in-cheek. You're welcome to borrow it in your own presentations, and hopefully as kind of a part of approaching our work in this space. So design how? For whom? Benefit, what does benefit mean in this context? Who benefits, right? That's a key orientation from the many fields that compose social justice. Who benefits? And specific communities. Which communities? What specificity becomes relevant here? So I'll go back and hopefully answer some of those ethical asterisks. But first, I'll kind of get you from where we've been in all these other talks, which have been so great, into the kind of robotics universe. So we already live and work amidst autonomy, lots of types of autonomy, and the stakes are going to get higher. Now, we've seen from a lot of different systems that autonomous systems, algorithmic systems affect what we see, what we find, what we read, what we know, who we know. That's kind of the information that we see. But it goes also inside us into how we behave, what we believe, who we think we are, right? And I'm not talking about robots right now. I'm talking about social media. I'm talking about advertising platforms, content platforms. So these autonomous systems have these wide-ranging effects. How do they do that? They make marks, right? Words, numbers, tags, images, video, it's information, right? It's marks. Now, in addition to the ethical asterisk, I've introduced another thing here, which I call the disciplinary dagger. That's the name for that little alternate asterisk, the little cross symbol. And when I say marks here, for anyone who is might be thinking, hey, that's inscriptions. Yes, that's the kind of technical term. There's a bunch of literature on inscriptions, materiality of information. So that's the kind of thing I'm talking about if that is a disciplinary connection for you. But disciplinary daggers go away. So the effects of all these systems follow just from these marks, which is really pretty amazing, right? And I think that's one of the mechanisms whereby we didn't quite understand 10, 20, 30 years ago, the scale of change that would happen. These marks have a lot of impact. And I want to note, too, that this connects to things like surveillance, things like data collection, right? In digital systems, and this comes from more a disciplinary dagger, right? Wendy Chun. In digital systems, every read is also a write, right? So every time you're surveilled, that's written somewhere. So that still is kind of analyzable as an inscription or a mark. So let's situate ourselves in this conversation. What are autonomous robot systems going to do? Well, they're going to bring us things. That was our starting point with delivery. They're going to care for us. Talk a little bit more about that at the end. Some of the projects I'm not going to be able to talk too much about. They're going to protect us. Are they going to police us? We've started to pay a lot of attention to the public coverage of robotic deployments, and there's a lot of anxiety about these things. Now, regardless of what they are doing and what they will do, right, robots take action. Now, inscription, marks, all those things I've talked about, images, video, those are also actions, right? But it's a very subtle one. And that's kind of the interesting thing for me coming from the field that really does this philosophy of language, or, what is an image in terms of an act, right? Well, the robot's doing things, right? We don't have to engage with that kind of theoretical subtlety. And so the effects of robotics are going to come from these physical, unambiguous actions in the world. So the stakes of getting it right are huge. One of the wonderful things about working with robots is that it's really behind the rest of technology, right? And so in a certain sense, we're time travelers. We're going back to 1995, and we could have an impact on the future of the internet or something like that. There's a lot of great things that we can learn from how other technologies have developed, and hopefully we're early enough in the adoption cycle of robotics to really have a huge impact. And that impact needs to be commensurate with the impact that robots will have. So again, backing up to kind of AI more generally, here's a simple model of the impacts that AI has on the world. Algorithms, they make some marks of some kind, and those marks have effects. On this simple model, I can put in this model of what ethical AI might be. Here's one vision of it. Well, we connect the effects back into the design of the algorithm and make them better. Now, you see the ethical asterisk here, right? What is better? For whom? Big questions, right? And good systems. There's some ambiguity in what good means. And that's okay, right? Then I've learned a lot from my colleagues in communications. In communication studies in the beginning was thinking, well, more explicit communication is always better. Ambiguity is space. It's space for different interpretations. It's space for change. It's also space for apathy. It's space that can hide harm, right? So that's what the asterisk means. It doesn't necessarily mean they'll do that, right? It means know what we're doing when we leave these kind of spaces. So on this simple model, this is kind of a map of some of the subfields of robotics I gestured to earlier, right? Robotics is not, as we perceive it from the outside, this kind of, oh yeah, we're all doing the same thing. They're very, very subfields that are different from each other. So making robots do some things is broadly robotic autonomy. Robots need to perceive things, they need to move around in the world, navigate, and they need to control themselves, and we need to control them. Studying actions of robots and their effects is broadly what human factors in robotics, which comes out of the engineering field. And I will say that kind of intellectual legacy of human factors research is like the people that brought you why planes don't crash because pilots got confused. Right? It has this really, I think, great history, starting back in the history of aviation in human factors. So same thing, right? A system that's otherwise functional on paper that doesn't behave right because a human is in there and was confused or something's happening, that is that field. Human-robot interaction, computer science kind of pulled from human factors to really start studying human-computer interaction. And then that has morphed into human-robot interaction. So. And apologies for all of my colleagues in those fields because I glossed over them. Broadly, this is getting robots to do stuff. And the interdisciplinary field of robotics is focused on that, and kind of rightly so, right? It's a difficult, very interesting basic science challenge. How do we get robots to do stuff? But these actions are centered. So considering these effects in design, that big loop around the top is a start. Now watch what's going to happen here. Effects is over there. Oh! centering effects is another step in the right direction, right? And I've kind of remapped where these fields kind of fit in the diagram. Robotic autonomy in this conception of what ethical AI might be is starting from effects, then building robots that accomplish actions that have those desired effects. Now, interdisciplinary collaboration is also a great approach. And as I mentioned, that interdisciplinary robotics collaboration that this project was founded on brought in Junfeng Zhao and his experience from the School of Architecture in Smart Cities Research, Urban Studies, to really give some different methodological tools of understanding what kind of effects might happen if we deploy delivery robots on campus. Ethical asterisks all over the place, right? Effects upon whom? Now, there's a lot of human-centered AI, human-centered robotics, which is the name of my colleague Luis Sentis's lab, right? What we center is important, right? But upon whom? Humans is not an answer, right? When I say human, does that person that you might have envisioned have a gender, a nationality, a native language? No. Okay, we'll take those things away. What else do they have? Do they have a physical body of any kind with characteristics and abilities and disabilities? No, let's take that away. What's left if we take all those characteristics away, right? We have to, when we think of this default human, we kind of have to give it some shape. And when we do that, we privilege some kinds of humans, right? It's a difficult move. So our approach to some of these challenges, which is not the only one, and we'll see how successful it is, but here's what we're doing. Effects upon humans. Let's try and expand out from humans, which, by the way, there's been some critiques of psychology research talking about weird undergraduates standing in for the human. Weird stands for Western, educated, industrialized, rich, and democratic, right? The kind of undergrads from Western countries kind of represent the human that psychology studies, right? And this is changing, but we'll kind of expand along two dimensions. The dimensions of kind of who counts and the specificity of a specific community instead of kind of arrogating what we're studying as the human as such. What is a good effect? Well, in existing studies, in robotics, it's like, well, this robot was effective. It achieved the intended effect. And when humans are included as participants, the humans weren't freaked out. Technology was accepted, right? There's models of technology acceptance. Well, yeah, that's a foundation, right? And this is a little bit of a sleight of hand here. I'm putting all of the non-answer to that, what is a good effect, into a new term that I haven't defined. But that's part of the research, right? We're talking about pro-social. There's some ambiguity in what pro-social means, but there's also, it's closed off some answers. Pro-social means good for communities in the context of a community. And so especially combined with the answer to the first one, there's some real specificity there that we need to fill in with our empirical work. So how do we know? A lot of existing work happens in the lab, right? And there's a lot of practicality to that. When you're working with expensive hardware, you want to instrument the scene, things like that. There's a big movement in a lot of fields that study humans and robots together to get the research out into, quote, the real world, which is good, but ethical asterisks, right? Whose reality are we talking about? What represents the real world? And it's probably, in this case, not weird undergrads, but a weird campus. And that's certainly a critique of our project, right? We're going to deploy robots on UT's campus, but we're trying to be very deliberate about the specificities of place and not, again, arrogate our research out to represent more than what it actually does. So this all comes together into what we're thinking of as kind of a new interdisciplinary field, community-embedded robotics. We're not the only group doing this, but there's not yet a label that all of the people doing work related to this kind of accept and say, yes, we're doing that. So this is our suggested term, and we're holding a series of workshops and really trying to build a scholarly community around this bigger than just us. But enabling pro-social life amidst robotic autonomy is kind of the grand challenge of that interdisciplinary field. So in our project, we're studying the technical, right? And we talked about robotic autonomy. You want to make robots aware of things. Right now, a lot of the research is making robots aware of the built environment or aware of the terrain conditions, things like that. How do we make robots aware of community? Things that are relevant to community members, to really perceive the contextualities, just even the difference between when classes are changing and there's a bunch of people on Speedway versus, the weekend or the summer. There's some even basic things about the built environment that communities impact. Community factors for robotics. That's that vector of expansion, right? It's very difficult to measure that human-robot interaction, or even more than one human, more than one robot. Well, let's explode that out. Can we measure the interactions and the factors that come from one robot or multiple robots with 100 people, 100 pedestrians? And same dimension of expansion and community-robot interaction. We're combining those technical subjects with social research, right? Community impact. When we actually deploy these in the real world, right? Let's take those quotes out. We're on the real UT campus, right? What happens? How do we know? What research methods do we need to mobilize to make sure that we're not just studying the people, right? But studying the people, modifying our methodology to make space for both the robots and the communities as well. We're studying our own research practices. So this is the field of science broadly, science and technology studies, team science, organizational communication, and trying to kind of engineer the best practices, but also identify challenges that we're encountering that we might not be able to overcome. There may not be best practices, and surface those to our research communities as challenges for this kind of work going forward. And of course, bringing critical and theoretical perspectives to robotics. Again, I think it's really wonderful to be in robotics because it's kind of behind where, for instance, critical computer science is. So critical HCI, human-computer interaction, is a very robust field. And so it gives us a nice roadmap for the kind of communities. And again, this work is already happening. There's a groundswell of this, but we want to participate and encourage it. So in our project, what do we center? Community robot encounters. Okay, that's our shared kind of unit of analysis. And we bring kind of all of our fields, expanding in this kind of coordinated way to encompass this as a phenomenon. And so that means different things for the different places that our team is coming from. But this convergence is in the form of expansion. So technology seems to come in discrete pieces, right? What is this? 3 Amazon Echo dots, right? And those pieces, there's a big, influence, commodification, right? Each of these things has an SKU and is a saleable unit. Well, convergent research reveals a massive whole, W-H-O-L-E, around it. Also, in this case, it reveals a literal whole in the form of the strip mines that are used to get the rare earth elements that are essential to build the chips for the Amazon Echo Dot. Right? So this is not our work. This is from Anatomy of an AI System by Kate Crawford and her colleague, it's in my notes here, his first name. I might not have put it in. Apologies. I think it, anyways, Jolaire in 2018. Anatomy of .ai. I highly recommend it. This is a very high quality kind of vector graphic. You really want to zoom in and spend some time with it, and there's an accompanying essay. But by really exploding an Amazon Echo Dot into the socio-technical, geopolitical connections all around it, right? That's an illusion, right? There's a move that we make to say that's a discrete thing. And when we make the opposite move and reveal these connections, that kind of convergence reveals a different picture. So our challenge, can we see these pieces as a whole that influence community robot encounters? How can we study all of this at once? Now I'll tell you a little bit of specifics. So this is a diagram from an under review grant proposal talking about how we can get rich data, multimodal, kind of heterogeneous data on community robot encounters. And these are kind of robots moving through campus. Some of our colleagues want to collect physiological data so we can measure kind of stress responses and calibrate that on our participants. Others of us are looking at more the behavior of crowds, right? So it's not about the individual necessarily, but it's about the behavior of crowds. Others of us are looking at the behavior of robots, the autonomous behavior, what their control systems told them to do at different times. And we want to link all this together, including with things like interviews, follow-up interviews. So someone has an encounter with a robot, and maybe we were able to get data from the robot, from the sensors. Maybe we were able to observe that in person. Maybe we were able to get that person to come do an interview. Can we index all of this heterogeneous data? It's going to be sparse, right? We're not going to have all the data types for every community robot encounter. But can we link it together so that as a team, when we have a kind of encounter, or maybe even a specific encounter, that we could really go benefit from our colleagues' expertise from other data sources and understand that more fully. So our kind of nitty-gritty strategy for this is convergent data modeling. Taking all of the different types of data that inform all of the different research methodologies that happen on our team and bringing it together. Under the hood, I didn't put a disciplinary dagger for this, but here's a verbal one. Right? This is a graph database, right? It's very sparse. Community Robot Encounters is the main kind of node in that graph database, and when we collect data, we will link it, index it to a specific encounter. And like I said, it's sparse, so we're not going to have an interview for every community robot encounter, for instance. But over time, we'll build up a really valuable data set. Now, if we really want to support this field of community-embedded robotics, we need to integrate our team in terms of research and also think about that external community. So over time, this kind of database of data that we have on community robot encounters forms a resource that we can, in a way that's sensitive to privacy considerations, of course, publish off to really provide resources for people in all sorts of the fields that we're engaging with to use this data more broadly. Of course, we prototype those uses internally, but then once it's ready, this becomes a major contribution. So what we have been led by in our grant proposal and NSF's kind of real fascination with the idea of convergence, to consider a convergence instrument, we're calling a testbed observatory, right? So an engineering testbed is a place that real world, aspects of the real world relevant to the functioning of devices that we're building are there. And so aeronautics testbed, drones testbed, et cetera. For us, the UT campus is a testbed for autonomous robots embedded in a community. But it's also an observatory. So that data collection, that heterogeneous kind of convergent data model that I mentioned, will be fed by data over time. Now, the interesting thing that this enables is that rare types of interactions are something that we'll be able to aggregate. So let's say once a month something really interesting happens. Somebody encounters a robot and tries to do something interesting, with it. In our lab-based experiments, that's kind of data that we would exclude. But with an observatory, we can go back and put together a data set that lets us really understand the edge cases of interaction. So this is the overall plan, and it kind of leads towards this idea of repurposing. Repurposing, the kind of grand challenge in robotics is general purpose autonomous robots, right? The kind of sci-fi robot. Do this thing. Well, the robot's never done that before, but it can figure it out. Well, multi-purpose robots are a step towards it. Now, of course, I forgot to call out the whose purposes, right? Ethical asterisk here. Our answer to that is, what does community purpose look like? These robots are going to be doing jobs, hopefully to support the university's mission, and I'll talk about libraries as a component of that. But when you as a pedestrian encounter them on the street, does the robot care at all about you? Is there any way for you to interact with it? And so we're looking into playful encounters. Is there a way that robots can indicate a receptivity to play? That's something that you can do. This is understudied in the literature and an example of the kinds of things that a community might use. The other thing is, not just the kind of pedestrians, but the kind of stewards of a community. Disaster response. So in disaster response, you can build a special purpose robot, but that's expensive and you kind of use it a few times. These robots that are deployed, can we repurpose them to really help with disaster response in a way that's coordinated with those that care for the community? So some additional projects I can come back to, but we really want to do an ethnographic understanding of what library labor is, not with let's put robots in the library, but just understand what are the possible surfaces of deployment. And we really want that to be a potential case study and kind of the right way to do that. Domestic service robotics, what is the construction of the domestic? Just like I talked about, what is the default human? What's the default domestic that these service robots are being built for? We've seen a lot of narratives of care of elders, and things like that. How does that match up with practice and with benefits to those communities? Repair, configuration, there's a lot of work behind the scenes that goes into robotics. What does that mean for robotics research? Also cyber infrastructure training. I hope I'm not spilling the beans too much, but we do have an English professor in the lab who's been taking a lot of notes, and I imagine going off to his study and writing about it, so potentially something to look for. So just to wrap up, let's ask the right questions in the right way. There's ethical asterisks all over this slide, and I hope you'll help us fill it in. By whom, for whom, which communities? And again, I'm really honored to be doing this for a big team. I'm just the one presenter. You're welcome to reach out to me, or of course, look at the full team online. Thank you so much.
Thanks so much, Elliott. We have a few minutes for questions before lunch.
Hi. In this slide where you talk about playful interactions with the robot, there was a spot robot on that slide.
Yeah.
And so the question I've been thinking about is in the design of that robot, it's designed to look like a dog. So we have some mental model for a dog. I play with the dog.
Yeah.
I treat the robot similarly. And so as we try to develop robots in all these different modalities that maybe don't look like dogs, how does that mental model change the way that we expect to interact with those robots? If it looks like the little four-wheel delivery robots on some campuses, that's a lot less playful. And so how do we go about studying these things in maybe a more quantitative way when the thing that's changing is how we've built the robot? We're presuming how you play with it before anyone ever touches it, right? Is there not some presumption there?
Well, it's a great question. So I'll start with the last piece, right? Touching robots is something in the literature, right, that's called haptic interaction. And it's kind of given to this naive person who sees a robot wants to touch it, right? And there's just been this call to kind of develop for it, but that hasn't really manifested because it's complex. So that could be a future area of research. But you're exactly right? We do have this mental model of four-legged things and why we might see them on campus and what scenarios in which that's okay and what scenarios we need to be a little nervous about it. And we are studying that. So broadly, there's not a lot of HRI research on quadruped service robots, more like the pet style, right? And so when we talk about encounters, right, the encounterer is not the user of the robot. That changes the kinds of things, if we really want to design for encounters, it changes the kind of things we might want to do. So my colleague Justin Hart is doing things in enabling these kind of quadrupeds to do canine body language, to engage in playful things like fetch. We can see how that goes. We're also exploring the metaphors of service dogs as a way to indicate that these dogs have, these quadruped robots have a job. And just like when you see someone with a service robot or you see a service robot on campus, it's kind of okay. What are the aspects of that we need to kind of construct and consider in robot design to really activate those metaphors so it's not disturbing or as it could be to see them.
Thank you. Great talk.
Thanks.
Hi, I was just wondering, in your lab, for your living and working with robots project, do you explore how racial algorithmic bias affects AI technologies such as facial recognition, and like how biased data sets have a role in racial detection and computer vision for robots?
So not yet, but I appreciate you bringing that up, and that's one of the major points of collaboration. As I mentioned in an earlier question, you may or may not have been here, I think we're going to be a consumer of the research that comes out of some of these other core research projects, right? So yes, computer vision is used in robotic autonomy, and we have to be aware of the research on racial equity in computer vision, for instance, right? It's going to take some time for our kind of community embedded approach to get out into the UT community and kind of engage with sub-communities. So right now, library staff is really the first kind of sub-community on UT campus that we're going to engage with. They're going to be kind of users. And our testbed observatory, when these robots are out there, then that's when we start kind of engaging with community members. So it's on the radar for sure. And I think we will probably aim to be consumers of best practice in those fields. Because this is such an integrated thing. We want to innovate in kind of some of these other areas, but make sure that we're not kind of taking things off the shelf uncritically.
I just want to add one thing. So we actually had an NSF grant. Many of us collaborate on this. The topic is how to design ASIC robot. Not just the visual, also the voice recognition. For people like me who doesn't speak standard English, I hope my robot can understand me, not just by a voice. Actually, that's an active ASF grant. Many of us are working on that.
Yes, I'm interested in that as well.
Yeah, no, thank you. So Zhengfeng Zhao, he was out of the room earlier, and one of the PIs or the lead PI in that ethical robotics education for our doctoral programs. So keep an eye out for some of that curriculum that's happening. Dr. Fleischman is one of the curriculum directors on that. We really hope that can be the mechanism for us as a community to kind of share that expertise.
Thank you.
And Dr. Sentis over here might have another answer.
Well, I was going to ask the question.
Luis, you know all the answers. Didn't I answer your question?
Just thinking about my question and but if you want to elaborate more.
No, go ahead, please.
Yeah, so I wonder if, like cars, they go under a lot of certification. And here in San Antonio, for instance, SWRI, right, Southwest Research Institute, they develop a lot of the certification. And, in a way, robots walking in human environments, in pedestrian environments, is even harder than cars kind of moving the road. Perhaps they're not as dangerous because they don't reach speeds and they don't have the mass. Right. But do you see, and I'm part of this research, but then I'm just thinking of a follow-up of this research, or part of the research should be also create sort of some certification, right? Because these robots, some of them we're purchasing them from companies, and I don't know exactly what kind of warranties they provide. And then there is software that is already provided that we cannot touch. But then we might also be open to students developing their own systems. And in that case, we need to provide guidelines, right? So I guess it's a thought that I'm just sharing. And I wonder if you share similar concerns as well.
Well, I appreciate that. And this is our kind of what I mentioned, the human factors kind of excellence focus on safety. And Luis is leading that for us. So, we heard in some of our prior conversations about kind of the mismatches between technology and policy. And I imagine that UT Public Safety has rules for how you're supposed to operate a golf cart, but they don't have rules for how to operate a quadruped robot, certainly not an autonomous one, right? And so maybe there's a framework, again, we could be a consumer of how to try and lead that discussion and make sure that the policies are in place. The other thing I'll mention, there's autonomous driving is an active area of research, and there's a lot of stuff that we can import into robotics. But that combination that you mentioned, harder and lower risk, is beautiful, right? We might be able to make advances in pedestrian safety on the sidewalk with the kind of lower consequences of accidentally bumping into someone as opposed to seriously injuring them, that could then, via that harder task, inform autonomous driving. So that's kind of, I think, the goal. The final thing I mentioned, we're probably at the end of questions, but Sam asked me to mention the Amidst Gymnasium. That is, so Texas Robotics is a consortium, an interdisciplinary consortium, and there's a space in Texas, in Amidst Gymnasium, very near here, that kind of collects a lot of these. And so it's been really wonderful for the kind of non-roboticists of living and working with robots to see that space. And so we hope to have some events and potentially have things like makerspaces or ways for kind of non-majors, non-roboticists to get involved with this technology as part of our broader goal of engaging community members and what robots might be doing, but also just to kind of break down those barriers. It shouldn't only be experts using any of these AI-enabled technologies.
Well, it's a wonderful conversation, and now we can thank Elliott and continue the conversation over lunch.
Thank you.